Hello class, today we will be going over kinematic equations and their uses in real-world applications, as well as going over a few example problems and what they really are. So what exactly are kinematic equations? Well, kinematic equations are a set of four equations that can be utilized to predict unknown information about an object's motion if other motion is known, or other information is known. And to break that down quite a bit, it's using variables that you do know and manipulating an equation to find variables in that equation that you don't know. Moving forward, we have the equations can be utilized for any motion that can be described as being either a constant velocity motion or at constant acceleration motion. And what that means is that these kinematic equations only work under a preset set of rules and guidelines, and they're not always applicable when you're doing harder math. But for this class, they'll work just fine. So here are the big four kinematic equations. There are a few smaller, less used ones, but these are the four that we'll focus on here today. And the D stands for distance. Well, we also have a VI and a VF here in these equations. The VI is the initial velocity, and the VF is the final velocity. As well, in most of these equations, we also have an A, which stands for the acceleration of the object in motion, and T, which is the time it takes whatever projectile or object in motion to finalize its velocity. So right now we can do an example problem using the previous equations. So the first problem that we're going to do is what is the final velocity of a projectile that starts at 15 meters per second and is speeding up at 3 meters per second for 3 seconds before it contacts an object. So here we're going to look for the VF. We need to find the final velocity. The VI is 15 meters per second. The A is 3 meters per second. And the T is also 3. So VF, which is the final velocity, will equal 15 plus 3 times 3. So VF will equal 24 meters per second. Now this example problem has a bit more going on. An object is dropped from an air balloon that is stationary in the air. It falls for 3 seconds before striking the ground. How far does it fall? Now, judging from that, you think that we don't have nearly enough information to do this whole equation. But when you look at it and you reread the problem, it says that the air balloon is stationary. So when the object is dropped, that means that the object is also starting from a stationary, which means that the object has an initial velocity of 0. Because it has an initial velocity of 0, that means that 0 times time is still going to be 0. So this whole first part of the problem can be crossed out. Now moving on from here, we have 1/2 times A times T squared. So in this instance, what is A? Well, A is gravity. So we have A equals G. And we all know that G, which is gravity, is a negative 9.81 meters per second. So from here, we can actually do quite a bit. We can plug it all in so that D will equal 9.81 times 1/2, which is a negative 4.905. So negative 4.905 times, once again, time, which is 3 seconds squared. So 3 times 3, which is 3 squared, is 9. So you'll have D, we'll come up here and finish this off. The distance will be the negative 4.905 multiplied by 9. And we are going to get a final answer of 44.145 meters. Now you may ask, where did the negative go? Well, because this is a distance problem, it's understood that it's an absolute power. Because it's an absolute power, we can get rid of the negative sign and just worry about the overall answer. So at this point, you may be asking yourself, why are all these stupid equations important, and why do any of these variables matter? Well, here are a few real-world applications that do a lot of good. If you're flying a plane over a village that needs a lot of medical supplies, but there's nowhere anywhere near to land the plane, you have to airdrop them. And using these kinematic equations, you can figure out when to airdrop these medical supplies so that they land right on top of the village. As well, you can use these equations to find the distance traveled by projectiles, such as in wartime or in sports if someone needs to find out how far they can throw a football or a javelin. And lastly, you can find the time it takes an object to reach that objective. So if you're hunting for sport or hunting for survival or trap shooting or anything like that, you have to figure out how long it takes that projectile to reach the objective. And using a kinematic equation, you can find that.